Hi guys, welcome back to Team Adams Teaching. This time we're looking at roots, square roots, cube roots, how to estimate a square root. And so why don't we start off with what they actually are. Square roots, such as square root of 25, what they're trying to find out is what number times itself is equal to 25. So this is not division. It's not 25 cut in half or anything like that, but it's what number times itself gives you that 25. And the answer there is 5. 5 times 5 is 25. So the square root of it is just 5. Okay. There are several perfect squares, or actually there's tons and tons of them, but these are some of the more common ones that you're going to see. These numbers that if you were to make a square out of it, and the side lengths were 1 and 1, or 2 and 2, or 3 and 3, the area would be 1, 4, 9, 16, and so on. So square root of 1, if you had something with an area of 1, what would its side lengths be? They'd each be 1. Square root of 1 is 1. 1 times itself is 1. Square root of 4, again, if you had a bigger one and you had an area of 4, what would its side lengths be? 2 and 2. And this is why they're called perfect squares. They come out with same number times itself. And so in this case, that's going to be 2. So what times itself is 9? That's 3. Square root of 16, 4. Square root of 5, 25. And of course, these are going to be kind of obvious. They're in order. Square root of 36, 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196, 14. And square root of 225, 15. As you work with square roots, these ones kind of just get stuck in your head. You see them all the time. So those are ones you'll usually have memorized as you go through. But what if it's not a perfect square? What if they want you to say how big square root of 40 is? There are more precise ways to estimate, but this is one quick way to find sort of an estimate that's pretty good. And here's what you do. You say, well, the square root of 40 is between what two other perfect square roots? And let's see, 40. 40 would be in between 36, square root of 36, square root of 49. So I'm going to put square root of 36 over here and square root of 49 here. So notice my square root is in between these two square roots. And I know the answer to this one. Square root of 36 is 6. I know the answer to this one. Square root of 49 is 7. So my answer is going to have to be somewhere between 6 and 7. So it's going to be 6 point something. Well, what point is it? If it's directly in the middle, it's going to be 6.5. 36 and 40, it's 4 units apart. And 40 to 49 is 9 units apart. So notice that my answer is going to be closer to this one than it is to that one. It's only 4 units away versus 9 units away. So in that case, my answer needs to be 6 point, and then something below 6.5, but above 6.0, and it's going to be 6.3. You could use a calculator to check your work. Let's see, 40 and the square root of it, 6.32555. Again, if I want to round it to the nearest tenth, you look here at the 2, the 3 stays the same, 6.3. If you had put an answer of 6.2 or 6.4, those would also be answers I'd mark correct. Again, you're not using a calculator. You are just estimating its size, and these are all relatively close to square root of 40. So let's try that same method on square root of 10. We don't know what it is. It's not a perfect square, but it does fall between the perfect squares of 9 and 16. So square root of 9 and square root of 16 are the perfect squares on either side of square root of 10. I know this answer. It's 3. Square root of 9 is 3. I know this answer. Square root of 16 is 4. Which means my answer is going to be between 3 and 4. If it was right in the middle, again, it'd be 3.5, but let's see. From here to here, it's only 1 unit away, versus here to here, it's 6 units away. To get from 10 to 16, 6 units. So now I know my answer is much, much closer to 3 than it is to 4. How much? It's probably really close to 3.1 and 3.2. I would even say 3.3 would be an okay answer as well. All of these I would mark correct as just an estimate, a quick estimate of what the square root of 10 is. If we check this out, 10, and we get our square root, we get, there it is, 3.1, but if you look at the 6 after it, it rounds up to 3.2. So notice these ones are obviously very, very close on there. So that's one possible answer. These ones would also be okay when you're estimating. All right, well then what is a cube root? Well, a cube root is when you're trying to figure out what number times itself 3 times equals whatever you have. In this case, 8. Is 1 times 1 times 1, 8? So you need 3 numbers that multiply by itself give you 8. Is 2 times 2 times 2 8? Yes, yes it is. 2 times 2 is 4, times 2 is 8. So here are some more common ones to the cubed root. And notice the little 3 goes here. If it was to the 4th root, you have a 4 there. If it was to the 5th root, you have a 5 there. If the question was to the 4th root, they want to know what number times itself 4 times gives you the answer inside. So again, they're in order. So not too difficult as far as knowing these answers, but notice that 2 times 2 times 2 is 8. 3 times 3 is 9, times another 3 is 27. So cubed root of 27 is 3. It takes 3 3s to get 27. All right, then we have cubed root of 64 is 4. Cubed root of 125 is 5. 5 times 5 times 5. Cubed root of 216 is 6. Multiply 6 times 6, 36, times another 6, you get 216. Square root of 343 is 7. Square root of 512 is 8. And square root of 729 is 9. Notice how they get big really quickly. We started out with 1, and now we're already at 729. So exponential or exponents make things bigger really fast. Okay. So last thing, how would we solve an equation that has exponents in it? And so here is some of it. Remember, we're going to be using the opposite of PEMDAS to take and solve this. We're going to be doing SADMEP. But I do want to remind you that PEMDAS, I also had said it at one point, it was PERMDAS. Exponents and roots go together, just like multiplying and dividing go together and adding and subtracting go together. So we're going to start by getting rid of the adding or subtracting, then the multiplying or dividing, and then the exponent or the root. So let's start. I'm going to add 3 to both sides, leaving me with 2x squared equals 18. Then I'm going to divide both sides by 2, get x squared equals 9. And then I want to do the opposite of squaring, which is the square root, to get rid of the squared. So the square root of x squared is just x. And then what's the square root of 9? So most people say 3. It turns out there's 2 answers here. What? 2 answers? How's that possible? Notice this little exponent here will tell you how many answers there are. So if it's x to the 3rd power, there's actually going to be 3 answers in your equation. If it's x to the 10th power, it's going to be 10 answers. Holy cow. All right, so what on earth could the other answer be? Well, 3 times 3 is 9. Is there any other number times itself that's 9? And some of you might be thinking to yourself, it's -3. If you thought so, you are correct. -3 times -3 is also a 9, a positive 9. So the answer is plus or minus 3. It's usually written like this, a plus over a minus sign, and it's read as plus or minus 3. The answer could have also been +3 and -3, if you wanted to write it that way. And either way, both are correct. Either one of these answers substituted into the original equation would give you 15 at the end. Okay. So we'll faster through the last one. We're going to do -2 minus 2, leaving us with 3x squared is 108. Divide by 3, divide by 3, leaving us with x squared equals 36. And then x squared, we want to get rid of the squared, so we do the opposite of, which is square root. Whatever we do on one side, we have to do on the other. That leaves us with x equals square root of 36 is 6, but remember it can be a plus or a minus 6 that you put in place here to get 110. So in this case, x is plus or minus 6. So that's all we have for roots today, and I'll see you guys later. Bye.